Alright, so we're going to start off today's video by looking at 12.5. Specifically, we're going to be looking at solving right triangles. So in these problems, they're going to give us pieces of a right triangle and they want us to find the remaining missing pieces. So let's start off by looking at number 2. Number 2 says that angle B is equal to 15.8 degrees and side C is equal to 12.2. So let's label. If you look at the triangle they gave you in the book, angle C will always be the right angle. So C is the hypotenuse. Okay. Angle A will be directly across from side angle C. So that means side A is opposite. And we got B and angle B. Okay. So remember, triangles have 180 degrees in total. Correct? And we know that angle B is 15.8 and angle C is 90 degrees. That's what that lovely little box means there. Okay, so then together that adds up to 105.8 degrees. Okay, so now that we have 105 degrees, we know that the remaining leftover degrees has to be angle A. So angle A is 180 minus 105.8, which is 74.2 degrees. The last parts we need to find are side A and side B. So what we're going to use is sine of A, which we know is opposite over hypotenuse. So this is A over C, or A over 12.2. And we know that A is 74.2 degrees times 12.2 is equal to A. So A is 11.739. And then we need to find side B, and side B is going to be cosine of angle A is equal to adjacent over hypotenuse. So this is B over C, or B over 12.2. So we get cosine of 74.2 degrees times 12.2 is equal to B. So B must be 3.322. Now, if you're wondering how did I know to pick sine and cosine, I just found that working with sines and cosines was easier. You can use angle B and use that as your theta for sine and cosine and tangent, cotangent, secant, cosecant, you name it. I use sine and cosine because I know for a fact that those are already readily given on the calculator, so that makes it a little bit easier, and you should keep that in mind when you're deciding what angles to use and how. Let's look at another example. For 8, we're given that A is equal to 52.5, so we'll label that accordingly, and B is 28.0. We don't know C, and we don't know our angles A or B. So first thing we're going to do is figure out side C. And what we're going to use is Pythagorean's theorem because we have a right triangle here, so we can. And later on in the lesson today, we're not going to be able to. So we'll have 52.5 squared plus 28 squared is equal to C when you take the square root. So C is going to be 59.5. Okay. And then we need to find our angles. So first I'm going to find tangent of A, and that's going to be 52.5 over 28.0. This is because I'm given 52 and 28, and it's usually a better idea to work with given numbers rather than found numbers, such as C, because what if you're wrong? Okay, so then this will be equal to 1.875. So then to find A, we're going to take the inverse of tangent. So A is equal to tan inverse of 1.875. There is a button on your calculators for tan inverse, so you will be able to do that. So tan inverse gives us an angle, so we get 61.9 degrees. And so then angle B, now remember, they're only 180 degrees in a triangle. So we know that 90 of them is taken up by angle C. So B must be 90 minus angle A. So this is 90 minus 61.9, or 28.1 degrees. And that's solving right triangles. Now let's look at the law of cosines. Okay, so it's another way to solve triangles, but these are triangles that are not specifically right triangles. We know how to solve right triangles, but what if we're given an angle, a triangle that looks like so? Okay, that's not a right triangle. This angle is much larger than 90. So this is where we bring in the law of cosines. So it says that in any triangle ABC, so that means that also if we have an acute angle on our triangle, we can still find our triangle, okay? C squared is equal to A squared plus B squared minus 2AB cosine C. B squared is equal to A squared plus C squared minus 2AC cosine B. A squared is equal to B squared plus C squared minus 2BC cosine A. You're going to probably want to put this on your note card just because there's a lot of variables to remember, okay? So then let's look at 2. 2, we're given B equals 12, C equals 17, and angle A is equal to 74 degrees. What is the value of the length of A? So what we're going to use is we're going to use this third formula here because we have B, we have C, and we have A, angle A. So we get A squared is equal to 12 squared plus 17 squared minus 2 times 12 times 17 times cosine of 74. This is going to be equal to 320.53996. So A is going to be equal to the square root of that, so that's going to be 17.9. Let's look at 8. 8, they told us that A is equal to 9, B is equal to 10, C is equal to 15, and they want us to find angle C. So all of the formulas that we have on this page here, they're all in terms of a length is equal to this, yes? Which is a problem because what we're looking for is an angle, not a length. But we can solve one of these formulas, or actually any of these formulas, for a specific angle. So first thing I'm going to notice that I have A, B, side C, and I want angle C. So I'm going to use this force formula at the top. So then I'm going to rewrite the formula down here. And then I'm going to use algebra to solve for angle C. So first thing I'm going to do is get 2AB cosine C on one side. So I'm going to add it to both sides, and I get A squared plus B squared is minus C squared on the right. Then I'm going to divide both sides by 2AB, and I get cosine C is equal to A squared plus B squared minus C squared over 2AB. And then remember that to find the angle, we have to take the inverse of both sides. So C is equal to cosine inverse of A squared plus B squared minus C squared over 2AB. So we're going to use this new formula down here to solve for our angle C in 8. So I'm going to plug in my values for A, B, and C. We've got 9 squared plus 10 squared minus 15 squared over 2 times 9 times 10. And this is going to be equal to, when I plug everything into the calculator, I'm going to get 104.1 degrees for C. And that's it. So if you're wondering on your homework, since you will be allowed calculators and on your quizzes, you just need to show me this setup here and all this work leading up to this setup, and then plug it into your calculator to get the answer. Let's look at 2 more examples for law of cosines. In 10, they tell us that A is equal to 30, B is equal to 20, C is equal to 40, and then they want us to find the largest angle. But they don't tell us which one is the largest angle, or do they? Commonly known idea is that the largest angle of a triangle is opposite the longest side or largest side. Okay, so of the 3 lengths given to us, C is the largest. Okay, so that tells me that angle C is largest angle. So I'm going to use the formula for number 8 to solve for C. So C will be cosine inverse A squared plus B squared minus C squared over 2AB. So this is going to be equal to cosine inverse of 20 squared plus 30 squared minus 40 squared over 2 times 20 times 30, which ends up adding to becoming 104.5 degrees. Now let's look at 12. In 12, they tell us that A is 1.2, B is 2.4, and C is 2.0, and that they want us to find the smallest angle. So using the idea that we talked about in the last problem, if the largest angle is opposite the largest or longest side, the smallest angle is opposite the shortest length or smallest side. So out of the three given, A is the smallest. So that tells me that angle A is the smallest angle. So I'm going to rewrite the formula for A squared. So we have A squared is equal to B squared plus C squared minus 2BC cosine of A. I'm going to rewrite this into the form we see above for angle C, but just with angle A this time. So I'm going to get the BC cosine A by itself and everything else on the right side. I'm going to divide by 2BC. And I get that A is cosine inverse of B squared plus C squared minus A squared over 2BC. So when we plug in all we have 2.4 squared plus 2.0 squared plus 1.2 squared, minus 1.2 squared, over 2 times 2.4 times 2.0. This is equal to cosine inverse of 0.8667, which is 29.9 degrees. If you're wondering how I'm rounding my answers, if you read in the instructions, they ask that most of your lengths be given in 3 significant digits and that the angles be given to the nearest 10th degree. So do keep that in mind when you're doing your answers for the classwork. Now let's look at our final lesson, that is the law of sines. So we've done law of cosines, we've done right triangle solving, now we're going to look at the law of sines. This also applies for any triangle, okay? So that means if we've got a large obtuse angle, like so, or if we've got a small acute angle, okay? In any triangle ABC, sine of A over length of A is equal to sine of B over length of B is equal to sine of C over length of C. This is all that we've got for law of sines, okay? So it's going to be a little bit easier to use than law of cosines, which can be unwieldy sometimes. So let's look at number 2. It says that C is equal to 12, angle A is equal to 42, and angle C is equal to 69. What is the length of A? So we're going to use this first part, sine of A over A. And then since it says that sine of A over A is equal to sine of B over B, which is equal to sine of C over C, we can assume that this first piece, sine A over A, is equal to sine C over C. So that's what we're going to use. So then I know what side C is, I know what angle C is, and I know what angle A is. So I'm going to plug those in. So I got sine of 42 degrees over A is equal to sine of 69 degrees over 12. So this ends up being sine of 42 degrees over A is equal to 0.0778. I want to solve for A, so then this is going to be sine over 42 degrees over 0.0778 is equal to A, which is 8.60. Let's look at 4. 4, they tell us that angle A is equal to 2.6, angle B is equal to 60 degrees, angle C is equal to 100 degrees. C equals what? So first thing I recognize is that, again, remember triangles have to have 180 degrees. And so then angle A must be 180 minus angle B plus angle C. So we have 180 minus 60 plus 100. So this is 20 degrees for angle A. Knowing that, I'm going to use the same exact formulas that I used in the last problem to solve for side C. So I'm going to get that side C is equal to sine of 100, which is angle C, over sine of A, which is 20, over 2.60, which is sine of 100 over 0.1315, which is 7.49. Lastly, we're going to look at 12, where we are given two sides and an angle. So if you notice in the previous examples, we were given two angles and one side. In this case, we're given two sides and one angle. What's tricky about this type of problem is that when you're given two sides and one angle, there is the opportunity to have more than one answer. Okay? And the reason for this is because since we're only given one angle, there can be a possibility of two answers. It's an ambiguous case here. Okay, so when we're looking at this in 12, we're going to get two answers. So when we solve for angle B, we're going to get two answers here. So first thing I'm going to do is I'm going to set sine of angle B over side B equal to sine of angle C over side C. And I'm going to plug in what I know. So I have sine of B over 15 is equal to sine of 40 over 11, which becomes sine of B is equal to 0.8765. And I get that angle B is 61.2 degrees, just from that portion. But because I can have two answers, there is a second option for angle B. So I'm going to take angle B, and I'm going to subtract it from 180 to get my other potential option. So I get 118.8 degrees. So B1 is 61.2, and B2 is 118.8 degrees. Now you're probably thinking, how do I know which case I'm looking at? So in this problem, if you notice, side C is smaller than side B, okay, and the angle we're solving for is angle B. So we have two potential answers. If you're looking at 8 in the notes, we're solving for angle A. So I'll just write this down. 8 is A equals 4.5, B equals 6.0, angle B is 35 degrees, and angle A is unknown. Okay. So first thing first, I'm going to reiterate this. We know that we can have two potential answers because the angle we're given is smaller than 90. Okay. So that's going to throw us off. Plus, we're only given one angle. In problem 8, the angle we're looking for corresponds to the smaller of the two sides, so there's only one solution. Whereas in 12, the angle we're solving for is the larger of two sides, so there are two solutions. Okay, so that's something to keep in mind, or maybe even to write on your note card and maybe discuss with each other while you're doing your classwork on Wednesday. And those are the notes. So classwork due Wednesday. Yes, I am aware you only have 30 minutes. You should be able to do this. If not, start it at home. Okay, classwork due April 4th. Page 577, 1 through 13 odd. Page 582, 1 through 11 odd. Page 588, numbers 1 through 11 odd. Again, if you notice my note on the slide, please bring a calculator. It'll make the calculations go way faster. As long as you show your work, we're good. Okay, so just make sure you show your work and bring your calculator. It'll make the problems go by really fast.